Welcome to this WiseOwl Excel VBA tutorial. In this video we're going to compare two techniques used to scrape websites, using Internet Explorer and using XML HTTP requests. We'll begin with a quick recap of controlling Internet Explorer using VBA. We'll explain how to navigate to a web page, check that Internet Explorer is ready, having finished loading the page, and then how to capture the document of the Internet Explorer object in an HTML document variable. We'll then explain how to use the XML library and how to open an XML HTTP request. We'll show you how you can send that request and then check that it's sent a valid response, how you can capture the response text in an HTML document variable, and then we'll show you how to parse an HTML table and write the content out into a new Excel worksheet. So let's get started. One of the main reasons for creating this video is to help answer a question that one of our viewers posted on a previous video in the series. So in part 47.2, scraping website tables and clicking links, a chap called Will Booth, I hope he doesn't mind me pointing this out, asked a question about scraping a specific website, all to do with betting odds for a golf tournament. So the website we're going to scrape is this one here called Odds Checker, and I thought making a video was a nice simple way to answer the question that Will asked. Another main reason for creating this video is to have a sort of formal reference point for comparing two main techniques for scraping websites in VBA. We have covered the two techniques in previous videos in this series, so part 47.1 and I think part 48 and 49 as well, cover both using Internet Explorer and also using XML HTTP requests. Now we've mentioned the use of the two different techniques in those videos, but we haven't got a formal reference point for it. So this video is going to help create that video that I can link people back to when they ask the question in the future. So to get started, what I've done is created a brand new blank Excel workbook. And what we can do is head straight into the Developer tab and open the Visual Basic editor, open up or insert a new module. And then we can start by creating a new subroutine called Scrape Odds using IE. So let's start with the Internet Explorer version. If you've watched any of our previous videos which use this technique, you'll be familiar with heading to the Tools menu and choosing References, and then setting a reference to two extra object libraries. First of all, to control Internet Explorer, we can set a reference to the Microsoft Internet Controls object library. So I can find that in the list and then check a box next to that to set a reference to that library. The other library I want to set a reference to is the Microsoft HTML object library. So this is the one that will allow us to loop through the various HTML elements and find the bits of the page that we want to write out into an Excel worksheet. Having checked those two boxes, we can click OK. Then we can declare a couple of extra variables. So let's start by declaring a variable to hold a reference to an Internet Explorer object. So dim IE as. I'll make this an auto-instancing variable so that I don't have to determine when I need to create a new instance of Internet Explorer. I can get my code to do that for me. So dim IE as new sh.view.Internet Explorer. Then I can declare a new variable which will hold a reference to an HTML document. So I'm going to call this HTML doc as mshtml.html document. Just so that I can see what's happening when I run my code, I'm going to make the Internet Explorer application visible. So I can say ie.visible equals true. And then I'd like it to navigate to the page that I pointed out earlier on. So I'm going to say ie.navigate. And then I'm going to pass in the URL by heading back to my previous browser, which is Chrome as it turns out. And then I can just copy the URL from the page I showed you, and then head back to my VB code and then just paste that inside a set of double quotes. Next, I'd like to capture a reference to the document of the Internet Explorer and store that in my HTML doc variable. So to do that, I want to make sure that the Internet Explorer application has finished loading the page first, and there's a few different ways we can ensure that, but let's go with a do-while loop. We'll say do-while ie.readyState is not equal to a ready state complete, or ie.busy. So a bit sort of belt and braces, but it seems to be a fairly reliable technique. And then we'll just continue looping around that until basically Internet Explorer has finished loading the page. When we've done that, we can say set HTML doc equals ie.document. Now I need to find out how I could potentially reference the items I want to write out into a worksheet. So let's return to the web browser I'm looking at this page in. It doesn't really matter if you're not using Chrome. You can find an item within the page that you're interested in. So if I find one of these cells in the table that I want to capture, you can right click on that item and choose an option similar to inspect. It might say inspect or inspect element or something along those lines. If I do this in Chrome, I get a new panel opening on the right hand side of the screen, which immediately highlights the item that I've just right clicked on and inspected. So you can see, hopefully if I zoom in, that this is a TD tag, a table cell. It has a specific class and a few other properties there. That TD tag is part of a TR tag, so it's nested inside a TR, a table row. One of the nice things about inspecting in Chrome is that when you hover the mouse over an individual item, it actually highlights that in the left-hand part of the screen as well. So that table row belongs to a table body, which is one of two sections in the table. There's also a table head. You can see if I flick between the two, it highlights those in the left-hand window. And those table sections are part of a table with a class called event table. If I just very quickly go up a little further, the table itself is part of or nested within a div tag with a unique ID, and this is something that I've been looking for. Unique IDs are great for referencing items in a web page. So I know there's a div tag called odds table container. I can reference that by its ID. I know that there's a table nested inside there, so one of its children is a table with a class called event table. So knowing that, I can work out now how to get references to those two things. Let's head back to the Visual Basic editor and declare a couple of extra variables. First of all, dim HTML div as an mshtml.ihtml element. So that can hold a reference to one single HTML element. I'll then say dim HTML table as mshtml.ihtml element as well. To capture a reference to the div tag, the one with the unique ID, I can say set HTML div equals HTML doc, and then I can use a method of that called get element by ID. So if I open a set of round brackets and double quotes, the name of the item or the ID of the item was called odds table container, and that will get me a reference to the div which contains the table that I'm interested in. Now the table that I'm interested in doesn't have a unique ID. It does have a class which is called event table. The problem with that is that there might be lots of elements in the same div which have the same class. There could be multiple event tables within that div. The table also obviously has a way to identify it using its tag name, which is just table. But again, there might be lots of tables in the same div tag. So if I'm using the class name or the tag name, there isn't a simple way to get a reference to a single element. There are methods I can use to get a reference to all of the elements with the same class name or the same tag name. If I can just briefly show you with a quick bit of sample code, if I say HTML doc dot and then get elements by class name or get elements by tag name, I could use those techniques. I can also apply those techniques to the HTML div as well. Rather than to the entire document, I can narrow this down to just the div tag that I've gotten a reference to. The annoying thing is that these methods don't appear in the IntelliSense, unfortunately. So let's say, for example, I wanted to get a reference to everything by tag name. Just use the name table. I can say set HTML table equals HTML div dot. Then get elements, and again you can see here that I don't sadly get the IntelliSense help, but get elements by tag name. Then in some round brackets and some double quotes, I can enter the name table, and then close the double quotes and close the round brackets. You may be able to spot the obvious problem with this. The name of the method is getElements by tag name, and I have a variable which can only hold a reference to a single HTML element. If I wanted this line to succeed, what I would need to do is change the type of this variable to an iHTML element collection, which returns multiple elements, as the name suggests. However, there's a quick way we can shortcut this. Rather than returning all of the possible tables in the div tag and then looping over all of the tables to find the one we're interested in. What we can do is treat the results of this method as a collection or an array, if you prefer, and tell it to return a reference to the first item in the collection that it returns, in a similar way to referencing worksheets or workbooks or other objects in VBA by their index number. So for example, I could say worksheets, and then rather than saying, for example, sheet 1 using its name, I could say worksheets 1 to return a reference to the first item in the collection. Now in the HTML library, the elements, or the collections I should say, are indexed from 0 rather than 1. But if I simply open a set of parentheses after the get elements by tag name and then enter the index number of 0, close the parentheses, that will get a reference to the first table in the collection of elements returned with the table tag. At this stage, all I'd like to try to do is write out a bit of sample information about the table just to see that this is actually working. So let's use a debug.print statement, and I'm going to refer to HTML table.className. I'll then make sure I can see the immediate window by heading to the View menu and choosing Immediate Window or pressing Ctrl and G. And then if I were to run the subroutine, bear in mind this may take a little while, it's going to launch Internet Explorer, it's going to try to browse to that page, it's going to wait until it's all ready. That might involve loading some annoying adverts and pop-ups, but eventually I get to the point where I've extracted or captured a reference to my event table, and I can see its class name written out into the immediate window. If I just close the Internet Explorer window here and then just switch back to Chrome, just so that we can see that I have indeed captured a reference to the table that I'm interested in, its class is event table. So that's one technique we can use to connect to a web page and get information from it, but it's not necessarily the most efficient. It involves waiting for Internet Explorer to load and then connect to the web page and then present it, wait for any pop-ups and adverts, etc. to appear before we can actually capture the information we want. A potentially way more efficient technique to use is to connect to that web page without using a web browser at all, using something called an XML HTTP request. Just before we do this, if you're interested in the documentation for this, and there's quite a lot of it, I should warn you, but this is the page you're probably interested in starting at, the MS XML library. So I'll just zoom in so you can see the URL there. So if you wanted to look this up yourself afterwards, this is the place to go. Now, there's an awful lot of information in here. I'm certainly not intending to cover absolutely all of it. What we are going to do, the bits we are interested in, are the XML HTTP request object. So it's a bit of basic documentation about the object itself. You can see a list of its members, its methods and properties and events. So what we're going to do is we're going to create a new XML HTTP request. We're going to use the open method, which will allow us to configure the URL we're requesting information from and tell it that we're using a GET request. And then we're going to send that request once we've opened it and wait for a response. And then we're going to use the response text property and capture all that response text in a new HTML document object. So that will effectively at that point give us access to the contents of the web page in the same way as using Internet Explorer, just a lot quicker. There's a few other specific pages as well. You can see the actual open method help page and the send method help page and the response text property, etc. So all that's available to you if you need to look that up or you feel like having a bit more of a read. The slight downside to this is that none of the examples are in VB. It's all in either JavaScript or C, C++ syntax. So you have to do a little bit of working out how to get this to work properly for Visual Basic. Anyway, let's head back to the Visual Basic editor first of all. And then to start with, I'm just going to copy and paste the entire subroutine we've written so far. The basic structure is still the same, and it'll be nice to be able to see what things we need to change if we just copy and paste the entire subroutine and then modify the name of it so that it says scrape odds using XML HTTP. Next, we'll need to set a reference to a new object library. So let's head to the Tools menu and choose References. And then in the list, we can find Microsoft XML. So let's scroll all the way down to the Microsoft section and then a little bit further, and there we go, Microsoft XML. Now you may well find several different versions available. I'm going to go with the latest version available, the version 6.0, and I'd recommend doing the same thing. Depending on which version of Windows you're running, you may see some slight differences here, but I'm going to go with the latest version available to me. Having done that, I can click OK. And then in my new subroutine, I'm going to replace, first of all, my reference to an Internet Explorer variable with a new one. I'm going to call it XML request, just for short. And then I'm going to make that, or declare that as a new MS-XML, or in my case, XML2, dot XML HTTP 6.0. So that's the version number that I've just referenced. If you've referenced a different version number of the library than I have, then you may see something slightly different, but in my case this is clearly the one to go for. As we're not going to be using Internet Explorer, we can happily delete the line that tries to make it visible, and in fact we should do that, otherwise the code won't work. We don't have an Internet Explorer variable anymore. Let's reuse the navigate line though. Let's not just delete that entirely. We'll need the URL, of course, but instead of using the navigate method of Internet Explorer, we're going to use the XML request dot open method. So there are several parameters of the open method which you can read all about, as I've just pointed out in the help pages. The first parameter is what method you're using. So what we're going to try to do here is try to get some information. So we need to state what method the request will use. So we're going to write get. We then need to put in the URL, which is what we already have in there. So that's what we're going to do here. We're going to use the same URL as we used in Internet Explorer. And then we're going to use the third parameter called var async. And this is to make sure that we wait until the send call is completed, so that we've got the fully formed web page returned to us rather than just returning immediately. So you can see here the default is true, which means it returns immediately, potentially before we've returned any useful information. So let's head back to the VB editor. And to specify all these things, we will open the request using a get method. We will pass in this completed fully formed URL, and then we'll set the third parameter, the var async, to false to make sure it waits until the full page has been formed. Next, we'll need to send the request we've opened, and then we should check that the request has sent a valid response, so that it hasn't returned some kind of error. Let's get rid of the do while loop. We don't need to wait now using a do while loop for Internet Explorer to be ready. We can then say XML request.send, and then we can check the status of that request. There's a status property. If I just switch again quickly back to the documentation, the status property shows you what values can be returned by an HTTP request. So what we're going to look for is number 200, which indicates that everything is okay. There are many other possible return values here for the status. Things you'll probably recognize 404 errors when you've not found the URL you're looking for, and there are many others as well. So you can use this table here to determine what to do in the event of some kind of failure. What we'll do is we'll just check for the status of 200, and as long as everything's okay, we'll proceed. If anything goes wrong, we'll just show a basic message showing what has gone wrong using the built-in default status text property. So to make that work, we can simply say if XML request.status is not equal to 200, then we'll display a basic message box which says XML request.status, so we'll get the number, and we'll concatenate that with the a separator character, just a hyphen, and the XML request.status text, or so where are we there? Status text, there it is. We'll then make sure that we exit from the subroutine, and then we can say end if. And at that point, we'll have the request sent and opened and hopefully succeeded. So all we need to do now is return the response text of our request into a new HTML document. So let's just make a quick modification to the HTML doc variable. Let's make it an auto instancing variable by declaring it as new. And then rather than setting HTML doc equal to the document property of Internet Explorer, we're going to say HTML doc.body.innerHTML equals XML request dot response text. From that point on, everything else should be identical to what we've done with Internet Explorer previously. So to test this, let's display the immediate window again. I can go to the View menu and choose Immediate Window, or as always, press Ctrl and G. Let's just clear the contents of the immediate window. And then if we run our scrape odds using XML HTTP procedure, we should see the same end result, but this time an awful lot quicker without the overhead of having to open up and control Internet Explorer. Okay, so that should give you an idea of the key differences in terms of the code you have to write to switch between using Internet Explorer or XML HTTP requests. You'll certainly see much better performance using the second technique, although it's a little more tricky to work with as you don't see anything visible on screen. It's a little more abstract, I agree, but I think the performance benefits are worth it. Anyway, all that remains, I suppose, is to help Will out and show him how to write out the content of that web page and that table that we've got a reference to into a new worksheet. So I guess at this point, unless you're really desperately interested in betting odds for golf tournaments, you might want to just stop watching. All we're going to do now is write a new procedure which loops through the various sections and rows and cells of this table and writes them out into a new worksheet. So let's head back to the Visual Basic editor, and I'll close down the immediate window at this point, and then let's create a new subroutine which we can call from either of our other two procedures. Again, just to demonstrate that at this point everything else is identical, it's just how you get access to the web page itself. So let's have a new subroutine called write table to worksheet. And I'll have a parameter for this method as well. Let's have a parameter called table to process, and I'll allow us to pass in a reference to an ms.html.ihtml element. So that'll be the table or the reference to the table that we captured earlier. So in order to call this one, just to demonstrate this from our scrape odds using XML HTTP, we will say write table to worksheet, and then we'll pass in our HTML table to our table to process parameter. Just to make our life easier and the code a little more readable, let's declare a few variables. Let's have one called table section as ms.html.ihtml element. And then rather than write that out many times, let's just copy and paste that a couple of times. And we've got table section. Let's have a variable called table row and another one called table cell. So all of those will be iHTML element objects. I'd also like to keep track of the row number and column number we're on to make it easier to write the information into the worksheet. So let's say dim row num, I'll spell that properly eventually, dim row num as long, comma col num as long. Finally, just one extra variable for convenience. Let's say dim output sheet as worksheet. And again, I'll spell that correctly eventually. There we go. We'll use the final variable we declared to create a new worksheet in the workbook and then capture a reference to it. So we'll say set output sheet equals this workbook.worksheets.add. What we're then going to do is start looping through the various elements of the table. So I'm going to begin by saying for each table section. So there are three sections to a table. There's a header and a body and a footer. So I'm going to say for each table section in table to process dot children. So the children are the direct descendants, the items, the elements that are nested directly within the table tag. So again, if I just switch back quickly to the memorial tournament, we can see that within the table at the next level down are the sections of the table. So table, then T-head, T-body, T-foot. There's actually nothing in the footer of this table, but this will effectively loop 3 separate times. So we'll say for each table section in table to process.children and then next table section. Within there, we want to loop through the individual rows in each section. So we can now say for each table row, and again, I'll spell correctly eventually, table row, for each table row in table section dot children. So again, the direct descendants of a table section are the table rows. Let's say next table row. Again, just to quickly switch back to the web page and show you that within a section, let's go for the body section just for demonstration purposes. And then within there we have the table rows. So TR tags, TR, TR, TR. Now within each table row, we have a number of columns or TD tags. So the children of a row are the table cells. So you can probably guess where we're going with this. We can say for each table cell in table row dot children. And just close that loop off, next table cell. And there's our basic loop structure for processing each individual cell in the entire table. Now each time I go to a new row and to a new cell, I want to increment my row num and column number variables appropriately. They'll be initialized to 0 by default. If it makes you feel better, you can explicitly say row num equals 0 and col num equals 0, or that will be the default anyway. But hey, it's good practice to be explicit about things, I suppose, in programming. Then for each new row that we visit, I'd like to simply increment the row number variable. So let's say within the for each table row loop, we'll say row num equals row num plus 1. We'll do the same thing for the table cell loop for the column number variable. So inside the for each table cell loop, we can say col num equals col num plus 1. The important thing about the looping through the table cells, looping through the columns, is that when we begin a new row, we want to reset col num back to 0. So after we finish looping through the cells in a single row, we can say col num equals 0 before we move on to the next row in the table. At this point, all we need to do is write out the appropriate property of each table cell into the cell in the worksheet indicated by the row number and the column number. So to make that work, let's refer to the output sheet variable and then the cells property. And the cells property allows you to reference a range object by its row number and column number. So we have nicely conveniently named variables row num and col num, and we can make the value of that cell equal to the inner text property of the table cell element. So table cell dot inner text. At that point, all we need to do is give this a quick test. So let's just quickly scroll back up to the scrape odds using XML HTTP. Bear in mind there'll be absolutely no difference other than performance. There's no difference whether you do this with the XML HTTP request or whether you just want to copy and paste this into the Internet Explorer version as well. Just one last thing you might want to do if you're using the Internet Explorer version is to say ie.quit to make sure that the application closes down at the end. Anyway, I'm going to go to the scrape odds using XML HTTP, and I'm simply going to run that subroutine, and we should be able to see that we end up with a new worksheet, although it's labeled as a workbook. There we go. I've got my new worksheet, and if I quickly click back, I've got all the contents from that table all listed out, not particularly beautifully formatted, I will freely admit. There's quite a lot of text in there, maybe a little bit more than expected, but we can clearly see that we're getting details from each row of the table, all the odds from the various different bookmakers for all the players in that table. If you wanted to compare performance or just prove that the same result will occur with Internet Explorer, feel free to head back to the VB editor and then run the scrape odds using IE routine. This will take a little longer to run because we have to fire up Internet Explorer and wait for it to load, wait for the adverts and the pop-ups and so on, and there it goes eventually, nearly. It's still running, still running, still running. It will get there eventually. You can clearly see the benefits of performance using XML HTTP requests just from this simple demonstration. There we go, finally Internet Explorer has finished, and there we go, we have the same output using Internet Explorer. It just took an awful lot longer to get there. The formatting is ever so slightly different here as well. I got some wrap text options for some of the cells that I didn't have with the XML HTTP requests, but nonetheless, we've got the same actual data, just took an awful lot longer to get, of course. One bit of information that is missing from this output, whether you're using XML or Internet Explorer, is the name of the bookmaker providing these odds. If I look back at the actual tournament table in the header section, I can see I've got these lovely little logos at the top in the table header section. But if I hover the mouse over the logos, although I can't really get the logos themselves, or at least I can't think of a quick, simple way to do that, I could get what is shown if I position the mouse over the cells, this little pop-up text which shows me the names of the bookmakers. So if I find out where that row is, I should be able to see in the table header section that we have a row here. There it is, the event table header row. So that has a specific class name. So if I know that that table row has got a class name event table header, what I can attempt to do for the cells in that row, if I expand a single one of them, this is the bet365, other bookmakers are available. I've got a little aside tag. I think it's a new HTML5 tag. I'm not that familiar with asides. What I am interested in here is the A tag stuck inside, the thing that holds a hyperlink basically. So we should be able to see in here there's a title property which contains the name of the bookmaker, and that's in the little pop-up text. So I could check that the row I am on in the table header section has a class name of event table header. Then I could capture the first A tag from that table cell and then return the title property to the cell itself. So bearing all that in mind, let's head back to the Visual Basic Editor and let's make a few changes to our write table to worksheet method. Let's declare an extra variable then that will be another HTML element, and we'll use this to capture a reference to the bookie link. So let's say dim bookie link as ms.html.ihtml element. HTML element, there we go, got it spelled correctly eventually. Now what I would like to do for each individual cell is first of all check whether the table row I'm on has a class name of event table header. So after incrementing my column number variable, I would like to check if table row dot class name equals event table header. Now remember, comparing strings in VBA is case sensitive, so it's important that I spell that with the same case as is listed in the web page. There are functions I could use to convert the case of the class. So I've got L case and U case, and then I can make that essentially case insensitive. But for now, I'll assume that I'm spelling it in the correct way. So if the table row class name is event table header, then what I'd like to try to do then is capture a reference to the first A tag within that table cell. So in a similar way to the way we captured the first table within the elements returned by the get elements by tag name property earlier, we can say set bookie link equals, and then we can refer to the table cell variable, and then refer to the get elements by tag name. Again, we'll have to spell that out, unfortunately, the IntelliSense doesn't work. And then in some round brackets and double quotes, make sure you spell this one correctly. The tag name is A, that's A, by the way. And then you can open up some round brackets and then enter a value of 0 to return the first A tag within that table cell. There should only be one, so we can guarantee that we can refer to that with the index number 0. Now, it may be the case that not every single cell in that event table header row has an A tag associated with it. So what we should then do is check if not, bookie link is nothing, then what we'd like to do is write out the contents of the title property of the bookie link into the appropriate cell. So rather than writing out the table cell in a text, what we'd like to do instead is say output sheet.cells row num col num dot value equals bookie link dot title. We can then end that if statement. We can then stick the other code that writes out the inner text in the else clause of the main if statement, and then end that if statement as well. Finally, what we should do is make sure that we set bookie link equal to nothing before we move on to the next cell in that row. So assuming that it isn't that we've captured a reference to the bookie link, we want to make sure that next time we go round, that variable is empty. So in this same if statement here, we will say set bookie link equals nothing. Okay, so having done all that, let's just give the whole thing another quick simple test. If I were to run my scrape odds using XML HTTP routine again, just for convenience and speed, shouldn't take too long. We'll get there eventually, a little bit more work going on because we've got all these if statements going on. But if I switch back to Excel now, we should find, if I just change the height of some of these rows here, we now have in row number 4 of the table, we've got the names of the bookmakers offering these odds. Okay, so of course there's plenty more scope for formatting the output of this. We're getting rid of rows we don't need and changing column widths and changing colours and font colours, etc., just to make it look readable. But I think at this point those things are fairly trivial and it's not worthwhile spending any more time in the video showing you how to colour things in. We've done that in plenty of previous videos and it's relatively straightforward to work out anyway. And the key points here in this video, of course, were working out how to use Internet Explorer versus XML HTTP requests and seeing the performance advantage of doing that. And then, of course, for Will himself, how you get the data from that particular table written out into an Excel worksheet. So hopefully that's made him happy. Thanks for sitting through this one. If you've made it to the end, well done. Hopefully you'll get some, I'll find some uses for some of the techniques we've seen there. And it gives us another nice example of scraping data from websites using VBA. So thanks for watching. See you next time.